Hey everyone, this is Nikhil. Welcome back to Smart Interviews YouTube channel, a one-stop solution to AC or Tech interviews. In this video, we are going to discuss the first three problems from the latest Codeforces contest 1034 Division 3. Now, without any further ado, let's get started. Alright, let's get started with the problem A. Problem's name is Blackboard game. So the problem statement says that initially the integers from 0 to n-1 are written on a blackboard. Okay. In one round, Alice chooses an integer a on the blackboard and erases it. Okay. There are numbers from 0 to n-1 on the blackboard and Alice picks one of them and calls it a. Similarly, Bob chooses an integer b on the blackboard such that a plus b mod 4 equal to 3. Okay. So there are n-1 numbers, that is there are n numbers which are from 0 to n-1 written on the blackboard, and in those numbers Alice picks one integer and calls it a, Bob picks another integer and calls it b, and Bob has to choose an integer b such that a plus b mod 4 should be 3. Okay, both Alice and Bob, after they picked an integer, they immediately erase that number from the blackboard. Okay, so rounds take place in succession until a player is unable to take a move. The first player who's unable to make a move loses. Determine who wins with optimal play. Okay, both Alice and Bob play this game optimally, and we have to simply determine which player wins the game. Okay, let's move on. So we have multiple test cases, and for each test case we have an integer n represents the number of integers written on the blackboard, and the output should be, for each test case, output on a single line, Alice if Alice wins the optimal play and Bob if Bob wins the optimal play. Okay, so simply it is, let's say if n equal to 2, if n is 2, we're going to have 0 to n-1 numbers on the blackboard. So 0, comma 1, n-1 is 1, so we have written 0 to n-1 numbers on the blackboard. So out of this, Alice picks an integer. Let's say Alice picks 1. If Alice picks this 1 and calls it a, Bob doesn't have any option but to choose 0. Okay, let's say Bob chooses 0. There was an extra condition as well. After both of them choose an integer individually, their combination, that is a plus b mod 4 should be 3. Here, if Alice picks a, which is 1, and Bob picks 0, 1 plus 0 mod 4, that is 1 mod 4, will be 1, which is not equal to 3. But as per the problem statement, you have to make this condition satisfied. But you have this condition here, which is 1. If it was 3, it would have been fine. But you have 1 here. Okay. Now we don't even have to write b equal to 0 here, because as soon as Alice chooses 1 here, Bob has to find a way to make this condition valid without even picking it. Now we have picked it manually to understand it, but Bob has to pick an integer such that this condition will be valid. Now that Bob doesn't have a move to make, it means that Bob doesn't have a move to make such that he will be able to make this condition satisfied. Since Bob doesn't have a move, he loses and Alice wins. As you can see, when n equal to 2, Alice wins, right? Let's discuss for one more test case as well. If n equal to 4, if n is equal to 4, the numbers written on the blackboard are 0, 1, 2, 3, that is up to n-1, which is 4 minus 1, 3. 0, 1, 2, 3. Okay. Let's say Alice picks 3 here. If Alice picks 3 here and calls it A, which integer should Bob pick here such that A plus B mod 4 equal to 3 condition will be satisfied? There's no other option except 0, right? Bob will choose the integer 0. Bob will choose the integer 0 such that 3 plus 0 mod 4, that is 3 mod 4 will be 3. This condition will be satisfied. And as soon as Alice picks 3, he erases it from the whiteboard. And as soon as Bob picks 0, he erases it from the whiteboard or blackboard. And you have 2 more integers left. And out of these 2 more integers, no matter which integer Alice picks, doesn't matter if he picks 1 or 2, Bob picks the other integer, and their combination 1 plus 2 or vice versa 2 plus 1 mod 4 will be 3. Let's say Alice picks 2, Bob picks 1, both of them erase. Now Alice has to make the next move. Now that Alice doesn't have any move to make, Alice loses and Bob wins, right? Here Alice picks, Bob picks, Alice doesn't have anything to pick next, hence Alice loses. Here Bob wins, here Alice wins. Similarly, let's also see it for n equal to 5. Let's also see it for n equal to 5. If n is 5, 0, 1, 2, 3. These are the numbers which will be written on the blackboard. Since both Alice and Bob would want to play optimally, they will play optimally here. Which integer should Alice pick here such that he will make Bob lose? Does he have any integer? Let's say if Alice picks 0. If Alice picks 0, in order to make this condition valid, which integer will Bob pick? Obviously, he has the option of picking 3, right? Okay, let's say Alice picks 1 here. If Alice picks 1, Bob picks 2, and this condition will be valid. If Alice picks 1, Bob picks 1. If Alice picks 2, Bob picks 1. If Alice picks 3, Bob picks 0, and this condition will be valid. What if Alice picks 3? What if Alice picks 4? If Alice picks 4, which integer out of these integers? Okay, obviously we will be erasing it. Now you only have these many integers. Now Bob has to make a move. Which integer will Bob choose right now such that this condition will be valid? So if he chooses this, 4 plus 0 mod 4 will be 0, 4 plus 1 5 mod 4 will be 1, 4 plus 2 6 mod 4 will be 2, 4 plus 3 7 mod 4 will be 3, and this condition is valid. Now Bob will pick 3 such that 4 plus 3, which is 7 mod 4 will be 3, and he has made this condition satisfied, right? Okay, Bob, since he plays optimally, he picks 4, he picks 3, and he will let Alice to choose the next integer. Now out of these 3 integers, let's say Alice picks 0, right? Since he is playing optimally, Alice picks 0. If Alice picks 0, can Bob pick any other integer here such that he'll make this condition satisfied? No, he doesn't have any integer from here such that he can pick from where he's going to win, right? So n equal to 5, Alice wins, right? Alice wins. Alice picks this. Bob doesn't have any valid move to make, hence Bob loses. Bob doesn't have any valid move, hence Bob loses here. And so on for n equal to 7 and n equal to 100. So what is the thought process behind it? let's just see for these test cases. When n equal to 2, Alice was winning here, because when Alice picks any integer, Bob doesn't have an integer such that he can make this condition satisfied. Hence Bob loses. N equal to 4. Whatever Alice picks here, Bob has had an integer to pick to make this condition valid, right? N equal to 5. For the first time, Bob had an option to make this condition valid, but for the second time, Alice has picked an integer such that Bob had no other option but to lose. Hence Alice wins. Alice wins here. So why is that happening like this? Why is it happening like this? Sounds like a math question, right? So why was Alice winning here? It is because you're starting with 1 and you directly picked 1. Doesn't matter what Alice picks. So everything is dependent on Bob, right? Alice can pick anything, but Bob has to pick an integer such that this condition will be valid. So the entire pressure is on Bob, not on Alice, right? So hence Alice won here. When you go to n equal to 4, you have 0, 1, 2, 3. So this was structured in a way that no matter which element Alice picks here, Bob has had an option to pick such that he was making this condition valid. But when you move to n equal to 5 here, n equal to 5, you'll have one more extra here, right? You have one more extra. Here, Alice did not have any move to make. Here, Alice has a move to make, right? Let's say this cancels out and Alice has a move to make. Alice picks 4. And Bob doesn't have any option, hence Bob loses and Alice wins when n equal to 5. I hope you have understood the logic behind it. Let's take n equal to 6. If you take for n equal to 6, let's say this cancels out. Let's say this cancels out. If this cancels out, Alice picks this and Bob picks this, right? Bob doesn't have anything but to pick 5. So 4 plus 5, which is 9. 9 mod 4 is 1, right? 9 mod 4 is 1. Hence, Bob loses. So, do you understand? It always depends on the last number here. Last number of the blackboard. Because, as you can see, if you pick this last digit, if Alice picks this last digit, Bob will obviously pick 0. If the last digit 3 mod 4 is 3, right? 3 mod 4 is 3. Because Bob will obviously pick 0 to make this condition valid. So whenever 3 mod 4 is 3, that is whenever n minus 1 modulo 4 is 3, Bob was winning. Because whatever Alice picks, Bob will also pick. But when n equal to 5, n minus 1 is 4. 4 mod 4 is 0, right? Is 0. This whole thing will be cancelled out. So in this situation, Bob wins, right? In this situation, Bob wins. But here we have an extra integer, that is Alice will pick this and Bob has no other option. And when we had 5 here, that is when n equal to 6, Bob still couldn't choose an integer to make this condition valid, right? Whenever n minus 1 mod 4 is 3, the other player will obviously have an option to pick an integer to make the condition valid. Whenever n minus 1 mod 4 is not equal to 3, other person cannot choose an integer at some point such that he will make that condition satisfied. Okay, let's go ahead with the code. Bit slash /std_h. We had multiple test cases. I'm reading the test cases as well. And we had an integer n represents number of integers written on the blackboard. And as per our logic, if n minus 1 mod 4, if it is 3, the other person will always have an option to pick such that he will make the condition valid. In this condition, Bob used to win, right? Otherwise, Alice will win. Let's try to submit this. As you can see, it got accepted. And let's move to problem B. So the problem B's name is tournament. So the problem statement says that you're given an array of integers a1 to an. A tournament is held with n players. Player I has strength ai. While more than k players remain, 2 remaining players are chosen at random. Okay, then the chosen player with the lower strength is eliminated. Okay, if the chosen players have the same strength, one is eliminated at random. Given integers j and k, determine if there is any way for player j to be one of the last k remaining players. Okay, so in order to put it in a simpler way, let's go to the problem statement. So let's talk about this test case. So we have 5 represents an array of integers, and each AFI represents strength of the ith person, right? And we have j and we have k. Here n equal to 5, j equal to 2, k equal to 3, and we have 5 integers: 3, 2, 4, 4, 1. As per the problem statement, what he is asking you to do is, when the number of integers are greater than 3, right? When the number of integers here are greater than 3, he is telling you to pick a pair of integers. So out of the pair which you pick, he is telling you to put the minimum. While more than k players remain, 2 remaining players are chosen at random, then the chosen player with the lower strength is eliminated. See, k equal to 3 and more than 3 players are remaining here. While more than 3 players are remaining here, 2 players are chosen at random. Okay, let's say 2 players, I'll pick 2 and 4. 2 players are chosen at random. Out of those 2 players, one with the minimum strength is eliminated. Here, since 2 is the minimum, 2 will be eliminated and 4 stays as it is. So the array will be formed as 3, 4, 4, 1. 2 has been eliminated here, right? 2 has been eliminated. Next, what do? As long as the number of integers remained are greater than k, that is greater than 3, you keep picking two random players, right? Since the number of players remained are greater than 3, you will pick two random players here. Let's say I'll pick 4 and 4. So for the equal condition, if chosen players have the same strength, one is eliminated at random. When chosen players have the same strength, since now 4 and 4 have this equal strength, one is eliminated at the random. Let's say I'll eliminate this. Now the resultant array will look like 3 4 1. 3 4 1. Right? So far we've just used n equal to 5, k equal to 3 in our conversation, but we have never used j. So j comes here, j equal to 2, right? J equal to 2. He's asking you, after you have done these operations, so why did we stop here? It is because we do not have more than k players remained here, right? We do not have more than k players. We exactly have k players here, hence we cannot pick two players at random. We'll stop it here. At the end, what he's asking you is j equal to 2 is a player with the strength 2. So at the end, he's asking you, by performing these operations, at the end, can you somehow make this person to stay in the remaining people? Is 2 remaining here? Because we have already removed 2. Can you somehow pick two random players such that 2 will remain unchanged, 2 will remain untouched here? Right? Let's just discuss this thoroughly for one test case such that you'll understand for remaining as well. So for 3, 2, 4, 4, 1. This j equal to 2, he doesn't directly represent the player with strength 2. He represents second player starting from here, right? Second player. He refers as second player. So he is first player, second player, third, fourth, fifth. Second player should stay untouched till the end, and you have to make moves in such a way. Can you make that? So here, since the number of integers remained or greater than 3, you will pick two integers at random. That is, let's say you pick 3 and 1. When you pick 3 and 1, since it is the minimum, it will be eliminated. It has the lesser strength, and the remaining resultant array will become 3 2 4 4. Since the number of integers here are greater than 3, greater than k, we'll again pick two integers at random. You can either pick 4 and 3 and delete 4. You can either pick 4 and 4 and delete 4. Let's just say I'll pick 4 and 3. If you pick 4 and 3, 3 is the minimum, so 3 will be deleted. Your resultant array will be 2 4 4. If you had picked 4 and 4, one of them would have been deleted at random, and the resultant array will be 3 2 4. Right? No matter what you do, if you do not touch 2, 2 stays untouched till the end. Hence you can say yes, we can make moves, we can choose to make these operations in such a way that the jth person will stay untouched till the end. Right? Here this person stayed untouched. Let us take a no condition as well. So we have a no condition here in 1 2 3 4 5 6. For n equal to 6, we have 1 2 3 4 5 6 and j equal to 1 and k is also equal to 1. Now what does it mean when the number of people are greater than k? You'll pick two players at random, right? Let's say now that we are trying to make this person stay till the end, let us not touch the first person. He's the first person. Okay, let's just touch these two for now. 6 and 5 I'll touch. So 5, since it is minimum, 5 will be deleted. Resultant array will be 1, 2, 3, 4. 5 has been deleted. 6. In the next move, since the number of people remaining here are greater than k, I'll pick two players at random. I'll pick 4 and 6, and I'll delete 4 since it is the minimum. I'll remain with 1, 2, 3. 4 has been deleted. 6. Next, since the number of integers remaining are greater than k, I'll pick two integers, that is I'll pick 3 and 6, and 1 with the minimum will be deleted. 1, 2, 6, 3 will be deleted, right? Here again, 3 numbers we have, and it should be greater than 1, and it is, we'll simply pick two integers. I'll pick 2 and 6. So we are doing this purely to make 1 untouched till the end. 2 and 6, we'll pick 2 and 6. Since 2 is the minimum, since 2 has the lesser strength, 2 will be deleted. So 1, 6. Since the number of people remaining here are still greater than k, you'll again pick two players at random. Now that we only are left with two players, you'll pick 1 and 6. Out of 1 and 6, 6 will beat 1 and 6 stays at the end. Now you can't do anything anymore because k is 1. Now we do not have more number of people here than k. We were able to make 1 come till here, but in the last step we were not able to make him stay. Hence it is no. J equal to 1 will be no. We cannot make j equal to 1 stay till the end. If j was 6, then we are able to make this person stay till the end. And if k was 3, these 3 would have been true, right? These 3 would have been fine. If k instead of 1, if it was 3, even we were able to make 2 stay till the end, we were able to make 6 stay till the end, as well as 1, right? So what is the thought process behind it? When do we print yes and when do we print no? Okay, before you listen to the solution, I would recommend you to go to this problem and try to solve it on your own. And if you're not able to solve it, come back and watch the video again. As you can see, in the first example, which element can we pick here? 3, 2, 4, 4, 1. Now we want the second pair to stay till the end, right? Now we'll make sure to not touch him, right? We'll make sure to not touch him. So what do? As you can see, the problem is only with the value of k, right? Because if k was 2, you're able to make this person 1 win. Doesn't matter. Even if j is 3, j is 4, we would have still made operations in a way that that particular j will still come here, right? When k equal to 1, we're not able to make it, right? When k equal to 1, we're not able to make it. Here, since k is greater than 1 here, as you can see, since k is greater than 1, let's say k is 1 here. In this case, let's say k is 1. And we want to make this 2 go till the end. Because 2 will not go till the end, right? The one with the maximum strength will only be the last person to stay if k is 1. The one with the maximum strength is the only person who stays till the end. Since j equal to 2 is not the strongest person, and if k equal to 1, he will not stay till the end. He will be defeated somewhere in between. If k is 1, And if j is the maximum element of the array, only then it is valid. Otherwise, even if k equal to 2 here, right, as you can see, even if k is 2, 3 or anything greater than 1, we'll be able to get 1 to every iteration, right? We'll be able to take jth person to every step. We've got 1 to this step, we've got 1 to this step, and so on, when k is greater than 1. But when k is equal to 1, we do not have that person 1, we do not have that person 1 carried out to the next step, because 1 is the minimum element. If j is 6, then it would have been valid, right? I hope everyone understands the logic. Let's try to write the code. We have two conditions here. We have n, j, and k, and we have an array of integers. So as you can see here, if j was 6, and k was 1, then the answer would be yes. And what is 6 here? 6 is the maximum element of the array. When k is equal to 1, the one person who will stay till the end is the one with the maximum strength. For that purpose, we'll use maximum. I'll declare a maximum variable here, max. I'll denote it with int min. I'm simply knowing the maximum element of the array. Okay. And as you can see here, except for k equal to 1, in all the other conditions, that is, in all the other conditions k greater than 1, we will be able to take the element j till that point, right? Here, if k was 2, we were still able to take 1 till this step, right? We were able to take 1 till this step until k equal to 2. But k equal to 1, we couldn't, because 6 is the maximum. Right? J equal to 1, k equal to 2, it would have been fine. Even 3, it is fine. 4, it is fine. K equal to 5, it is fine, and so on. I hope everyone understands the logic here. If k, I'll simply print if k is greater than 1 or so did we use j anywhere? A of j is the person who we want to take till the end, right? A of j is the person who we want to take till the end. It is not j. J is the index of the person. A of j is the actual person who we want to take till the end. If only this A of j is the maximum element of the array, if only this A of j is the maximum element of the array, we'll be able to print yes. Otherwise, we'll print no. If k is greater than 1, you can blindly say that you will be able to take A of j till the end and get it accepted. Or if k is equal to 1, it goes to this condition. If A of j, if it is the maximum element of the array, even in that condition, you will be able to print yes. If both of them are false, you will print no. Right? Since the j here is given in one indexed form, since we are dealing with 0 index, this j will become j minus 1. It is actually referring to j minus 1th element. Let's try to submit this. As you can see, it got accepted. Alright, let's move to the next problem. So the next problem is prefix min and suffix max. So the problem statement says that you're given an array A of distinct integers. So you're going to be given an array of integers where the integers are going to be entirely distinct. And in one operation, you may either choose a non-empty prefix of array A and replace it with its minimum value, or you can choose a non-empty suffix. The prefix or suffix which you choose should not be empty. That is, you have to include at least one element into your prefix or suffix and replace it with its maximum value. Okay. Note that you may choose entire array. Even if you choose the entire array, it may come under prefix or suffix. Okay. For each element AI, determine if there exists some sequence of operations to transform A into AI. That is, make the array A consist of only one element, which is AI. Now we have to output our answer as a binary string of length n, where ith character is 1. Okay. If there exists a sequence to transform A into AI, and you have to print 0 otherwise. Okay, got it. I hope everyone understands what a prefix and suffix is. A prefix of an array is a subarray consisting of the first k elements of the array for some integer k. A suffix of an array is a subarray consisting of first last k elements of the array for some integer k. Okay. So you would have understood the problem statement partially after reading the problem statement. In order to get the full clarity, you may have to look at the inputs, sample input and sample output. So this is what you have to always do. When you're not clear with the problem statement by reading here, you have to go to the input and try to understand what is being asked. Okay, so the number of test cases, you will be having multiple test cases and you will be given the size of the array followed by the array elements, and for output we have to output a binary string of length n. The ith character should be 1. So the ith character should be 1 if there exists a sequence of operations and 0 otherwise. Okay, what he's asking to do is, okay, let's take this test case for example. Okay, let's take this for example. Now he's telling you to either choose a prefix or suffix. Doesn't matter what size of prefix or suffix you choose, except for 0 size. So, can you somehow make this 1 stay here? That is what he's asking. Output has n space, that is let me write it like this. Okay. Now can you somehow make use of the transformations such that 1 remains as the only element at the end in the array? Can we do that? We can pick this entire suffix, right? Okay, instead of doing that, since in the problem statement itself it is said that we can also pick the entire array as suffix or prefix. So if you pick this entire thing and consider it as a prefix, what is he asking you to do? You have to put the minimum element, right? Choose any non-empty prefix of A and replace it with its minimum value. If I am considering this entire array as a prefix, he's asking you to replace this entire thing with the minimum value of the prefix. So what is the minimum value here? Minimum value is 1, right? Minimum value is 1. As you can see, by choosing this type of operation, we are able to make 1 stay till the end, right? 1 is at the end. Hence, you will be able to make these sequences on 1. You will print up 1 here, because you can make this 1 stay till the end. You can make this 1 stay till the end. Yes. Can you make this 3 stay? In order to do it, doesn't matter what you do, you have to simply try to keep this. Okay, let's say I'll simply pick this entire suffix, and when you pick a suffix, he's telling you to replace it with maximum value. If you pick suffix, you have to replace it with maximum value. If you pick prefix, you have to replace it with minimum value. Okay. Here the resultant array will look like 1, 3. This entire suffix has been replaced with the maximum value, which is 7. Now we are trying to make this 3 stay till the end, right? Can we try to do that? Okay, in order to make this 3 stay till the end, shall we take this as a prefix? If you pick this as a prefix, 1 will stay and 3 will go away, because 1 is the minimum of that prefix. If you take this as a suffix, 3 will go and 7 will stay in there. If you pick the entire thing and consider it as a prefix, 1 will stay. If you pick entire thing and consider it as a suffix, 7 will stay. No matter what you do, you will never be able to make 3 stay till the end. That is, you'll put 0 here, right? You'll put 0 here. That is, you cannot make 3 stay till the end by doing the operation in any which way you want. You do the operation in any way you want, but you have to simply make 3 stay till the end. You cannot do it. In the similar way, can you make 5 stay till the end? No, in the same way we were not able to make 3 stay till the end, we'll not be able to make it as well. So you'll put 0. We'll put 0 here, and at 7, what do you do? Since 7 is the maximum element, can we simply consider the entire array as a suffix and replace the entire array with the maximum value? So when I'm considering this entire array as a suffix, and they're asking us to replace the entire suffix with its maximum value. Maximum value is 7. That is, we are able to make 7 stay, right? We are able to make 7 stay. That is, we are able to make 7 stay. 1. We are able to do it. In the similar way, can we do the same with 2? Can we make 2 stay till the end? Can we somehow do that? You can do this process in any way you want, but you have to somehow logically prove that 2 will stay till the end. So let's just say that I'll pick this entire thing as a prefix, right? It is obviously a prefix because you're not including this. If you had included this as well, it is depending on your preference. If you want to pick it as a prefix or a suffix. Okay, let's say I'll pick this entire thing and consider it as a prefix. Since I'm considering it as a prefix, I have to replace it with the minimum value. If I replace it with the minimum value, it would be 1 and followed by 2. I have 1, 2 here. Now I simply do not want this. That is, I'll simply pick this. This is still non-empty, right? This is still non-empty. So what should we do? If I pick this as a prefix, I'll make 1 and 2 won't be there anymore. But if I pick this as a suffix, right? If I consider the same thing as a suffix, since the 2 is the maximum, 2 will stay, right? Since we are able to make 2 stay till the end, you'll simply put a 1 at its place. So that is, you can make this 1, 7, 2 stay till the end by doing whatever is told in the problem statement. For 13, 10, 12, 20. For 13, 10, 12, 20. Now, can you make 13 stay till the end? That is, can you make this array such that 13 will remain at the end as the only one element in the array? Okay, let's just say I'll pick this as a suffix and the resultant array will be 20 because 20 is the maximum element of the suffix and I've replaced it with 20. Now I'll consider it as prefix. This entire thing I'll consider it as prefix, and 13, since it is the minimum element, it will stay. Right? We have a chance here, right? We have a chance here, hence you'll write 1, that it is possible. Can you make 10 stay? Can you make 10 stay? How can you do that? Let's just say you have replaced this entire thing with the maximum, or even if you consider this entire thing as a prefix and replace it with its minimum value, 10 is the minimum value of this prefix, 10 will stay till the end, right? 10 will stay till the end, hence it is possible. It is possible with 10. Okay. Is it possible with 12 here? Can we somehow make 12 stay till the end as the only one element? Let's see. In order to make 12 stay till the end, let's just pick. If you pick 12, 20 as the suffix, 20 stays and 12 goes away. If you pick 13, 10, 12, you have to take the minimum element and 10 stays, 13 and 12 will go away. There is no other option to make 12 stay till the end. Since you are not going to do this, you simply put 0. You cannot make 12 go till the end. What about 20? What about 20? If you pick this entire thing and call it as a suffix, suffix will be replaced by the maximum element of the suffix. Maximum element is 20. So we are able to make 20 go till the end. 20 is the only element remained and all the elements have been deleted. Right? We are able to make 20 stay till the end. Hence, we can make 20 stay till the end. I hope everyone's understood the problem statement clearly. And now it is the time for you to build the logic. So you can always see other test cases as well. We have 1, 2, 3, 4, 5, 6, 7. Out of this, at 1, starting from 1, we are able to do it. Because if you consider this entire array as a prefix and you replace it with its minimum value, 1 will stay as it is. Hence, it is possible with 1. And it is 1 at the end because 7 is the maximum element. And if you consider the entire array and call it as a suffix will be replaced by the maximum element of the array. That is, maximum element is 7. And hence it is possible with 7. And doesn't matter which element you pick, you cannot make those elements stay till the end. Hence you have zeros here. Okay, why is it happening like this? So as you can see, for the first test case, you have 1000011. One thing you will be sure of, right? One thing you will be sure of. Let's say if the array is only having 2 integers, let's say the array is only having two integers. Let's call them 2 and 6. If the array consists only two integers, the output will always be 1 1, right? That is, if you consider this as a prefix, you will replace it with 2 and 2 will stay. You have an option. If you consider this as a suffix, you will replace it with its maximum, which is 6, and 6 will stay till the end. And both of them will have an option, right? 1 1 will be the answer. Similarly, you must have understood that minimum element of the array and maximum element of the array can always be ones, right? You can always make minimum element and maximum element of the array stay till the end, simply by considering ones as a prefix, considering ones as a suffix. So this is done. How are we making sure that even this is also possible? This is neither minimum nor maximum element of the array. But how are we making sure that even this is possible? That is, even we can make this go till the end. As you can see, if the prefix follows here, if you take this entire thing, it will be chosen as a prefix. And how do you know the minimum element? When you're here, you must know the minimum element of this entire thing. How do you know that? It is simply carrying forward the minimum element starting from the front, right? Out of all of this, only minimum element will stay here, right? If you take this as the prefix, the resultant array will be 1 and 2 because 1 is the minimum element. But when you are at 2, let's say you have printed all of this, when you are at printing this, how will you know that 1 is the minimum element in your left part? It is only if you can carry forward this 1, that is one. I'll write it as 1 3 5 4 7 2. 1 1 3 5 4 7 2. Here we have 1. You'll carry forward it to the front, and minimum element will be 1 1 1 1 1 1 till the end, right? When you're at 2, you'll simply check this value and you'll replace it like this 1 2. You understand that you can replace it like this 1 2, and you know when you consider this entire thing as a suffix, 1 will be deleted and 2 stays till the end, right? One thought process is this. In the same way we did prefix, what can be also done? What can be also done? Okay, here, why are we having 0 here and why are we having 1 here? It is because we have 13 is the minimum element so far. Here 10 will be updated to minimum and 10 goes till the end as the minimum element, right? 13, it checks, it works. Even for 10 it works. For 12 it is 10. 10 is the minimum element that is coming from the front. The left side part, 10 is the minimum element. You should not only be considerable about only the left part, you should also check the right part as well, right? So the right part, if it is coming from the right part, you need maximum, right? If it is coming from the right part, you need maximum. That is maximum from the end. So 20, 20, 20, 20, right? Now instead of 20, if this was a 11, if instead of 20, if this was 11, what would you have done? If this was 11, it would have been updated like this. Maximum so far is 11. Here we have 12, maximum gets updated to 12. And maximum is still 12 here, and maximum is 13, gets updated here. As you can see, if it was 11 here, you will be able to make 12 stay till the end. It is because if you pick the left side part at 12 is giving you 10 as the minimum element. 10 stays, right? 10 stays. And the right side part is giving 11. 10, 12, 11. Out of this, if you consider this as the suffix, 12 will stay till the end. Now, why weren't we having 12 in the result before? Because if we have 20 here, in the place of 11, we have 20. And 20 used to be the answer. We have to always make sure that whichever element we want to take till the end is the maximum in these conditions. So why was 10 working here? Why was 10 put as 1? It is because from the left side, if you pick something, 10 is the minimum element, right? For the entire part, 10 is the minimum element. And right part, it doesn't matter. Right? From the right part, it doesn't matter. Even so, we are having 20 because we'll pick all of them and 20 will remain at the end. So starting from 13, it should match to either of prefix or suffix. Let's call both of these as prefix and suffix. All of this will be 20, right? All of this will be 20. This is prefix, this is suffix. Now 13 should match with either prefix of I or suffix of I. That is, A of I should match with either prefix of I or suffix of I. Alright? Or if it doesn't match, it will be 0. Similarly, 10 should match either with prefix of I or suffix of I. It matches with prefix of I, hence it is 1. At 12, it doesn't match with either prefix or suffix, hence it is 0. And at 20, it matches with the suffix of I, hence it is true. I hope you have understood the logic. Let's say these were the minimum elements, right? To get the more clarity, let's say these are 9 and 6. Let's say these are 9 and 6. Here it gets updated like this. 13, 10 and 9 gets updated and 6 gets updated. Even suffix 6, 9, 10, 13. So in order to make 10 stay, what will you do? You will pick this, that is, it has to be the maximum at least, right? If it is the maximum, how do you know that? You will simply check with the suffix of I. Maximum from here, right? Starting from here, it should be maximum. If it is this the maximum? Yes. Because if this is the maximum, if 10 is the maximum, everything will be deleted and 10 stays as it is. Right? If 10 is the maximum element from here, which is a suffix, 10 will stay as it is. I hope you get it. 10 will cancel out everything. 13, of course, you pick it and delete it. You pick it as a prefix. Since it is the only one element and it is the minimum element of it, you'll simply delete it. I hope you've got it. Similarly, you can I have done it from the right, but you can also do it from the left. That is, I also have it from the left as well. That is, even prefix of I, I'm saying that you can pick this 13 and 10. 13 and 10, I can pick this, and the resultant value will be the minimum element, 10. And 9, 6, I can pick the entire array, and 10 stays as the maximum element, and 10 will become possible at the end. Okay, so let's try to write the code. We have multiple test cases. So we also have to have the prefix array and suffix array, right? I'll call it prefix of n and suffix of n, and I'll simply build both of them. So prefix of 0 will contain same as a of 0, and suffix of n-1 will contain same as a of n-1. So you'll have to simply build the prefix array. Prefix of I will be prefix of I-1 plus a of I. Sorry, I'm trying to get minimum till that index. Prefix of minimum element till the I-1 index plus current element. And same suffix of I will be max of suffix of I plus 1 comma a of I. Now we have both suffix and prefix array matched. Now what will you do here to print? So we'll simply print if a of I matches either with prefix of I or suffix of I. You'll simply print 1, otherwise no. At the end, you'll simply print a line. Let's try to submit this. As you can see, it got accepted. Okay, these are the 3 problems from the Codeforces Round 1034 Division 3. That's a wrap up to the video. If you guys liked it, please make sure to like, share and subscribe to 𝗏𝗏𝗃𝗲𝗹 YouTube channel. Thank you.